Welcome viewers. I will take today the comparison of basic character in various compounds. Kb stands for basicity constant and pKb is the negative logarithm of Kb. Greater the value of pKb, lesser is the basic character. Now, main point that you have to keep in mind is that the electron pair on nitrogen, if it is more available for protonation, the compound is more basic, and if this is hindered, the basic character decreases. I have taken several examples here. I will take them one by one. This is aniline C6H5NH2. Nitrogen has got 2 electrons in its p orbital and there are 6 parallel p orbitals in the ring. This is also parallel to these orbitals. So, this takes part in delocalization and it is diverted actually to the ring, that is not that much available as in ammonia. So, aniline will be a weaker base than ammonia. In case of diphenylamine, you have 2 phenyl groups, 6 p orbitals here, 6 here, and this one, they all are parallel on the same plane. So, this is delocalized towards both the rings, hence is less available than in aniline. Therefore, the basic character decreases, the value comes to 13.10. In this case, triphenylamine, you have 3 rings and this electron pair is delocalized onto these 3 rings and becomes very much less available, and that is why triphenyl is almost non-basic. Let us see aliphatic amines. In methylamine, you are seeing that there is a methyl group. Methyl has a plus I effect, it pushes electron density towards nitrogen, and this electron pair is thus helped in going away from it, that is in coordination with proton. Hence, as compared to ammonia, this is a stronger base. In dimethylamine, there are 2 methyl groups, both pushing electron density by plus I effect and making it more available. So, much basic than this. In trimethylamine, you have 3 methyl groups and you will expect this to be most basic of these, but it is not so, because although these 3 methyl groups push electron density towards this nitrogen, making it more available for protonation, yet there is a steric hindrance due to bulky methyl groups. So, because of this hindrance, proton is unable to reach this electron pair site and protonation becomes difficult. That is why it is a weaker base than these 2. In pyridine, you have this electron pair in sp2 orbital. The p on nitrogen overlaps with the ring p orbitals forming a sextet. This sp2 electron pair does not take part in this delocalization, hence it is freely available for protonation. Therefore, this is a stronger base than aniline. If you look at piperidine, here there are no double bonds, no delocalization, it is freely available for protonation and it is more basic even than ammonia. Pyrrole on the other hand has this electron pair here, this is delocalized like this, onto the ring. This p electron pair becomes part of the sextet and becomes less available for protonation. That is why it is a very weak base, 13.77. Let us see now substituted anilines. If X is NO2 nitro, this has minus I and minus M effect. Both withdraw electron density from the ring, attracting this electron pair towards itself, making it less available. So, all the three are weaker bases than aniline. This value 11.50 is in between the two, because this minus M effect of NO2, if it is put at meta position, it operates, this minus M operates at ortho, ortho and para. Meta remains unaffected. So, here only NO2 exerts the minus I effect. Therefore, this value is 11.50, higher acid than ortho, sorry, stronger base than ortho. In this case, you have minus M, minus I and plus M. Very strong minus I effect, chlorine. The plus M effect is subdued and this mainly shows the effect. So, when you are having this at ortho position, this minus I is the strongest because of the nearness, then comes meta, then comes para. So, here there is lesser withdrawal than here and then this. So, these values are accordingly. In case of methyl, you have plus hyperconjugate effect or plus M and plus I, both push electron density towards the ring, and hence this electron pair on nitrogen easily coordinates with proton because the electron density is pushed. This decreases with distance, ortho nearest, para far. So, here the effect is lesser than over here, than over here. This value 9.61 is higher than this, rather this 8.88. Try to understand this by the plus hyperconjugate effect of methyl group. Here if we put CS3, then there is close proximity, I effect is very stronger, plus M effect is also stronger, but because of close proximity of NH2 and CS3 at ortho positions, there is steric hindrance, and due to that steric hindrance, the planarity of NH2 is broken with the ring, and hence this plus M effect does not operate at this position, only plus I. Therefore, this value is slightly higher. This is all about basic character.